Madrid was born on November 11, 1930, in Brooklyn, New York City. Her parents were Polish-Jewish immigrants. She grew up in the time of the Great Depression, and this affected her from a young age. Madrid picked up a job to do piecework assembly tasks and to work at a zipper factory during her summers to help provide another source of income for her family. As she got older, she got her first teaching job as a tutor for special needs students. At the time, she was in grade school and only made 50 cents a week. However, through that experience, she learned skills she'd need in her future that she did not know yet. She learned the skills of how to be a good teacher. Where did she learn that she loved the field of science? Madrid stated that the New York's Free Museums, American Museum of National History, and the Metropolitan is where she found her interest in science. Time for a quick quiz question. What was Madrid's first teaching job? Was it A, teaching kids at the zipper factory, B, teaching her brother about money, or C, tutoring special needs students? Yes, the correct answer is C, teaching special needs students. Quiz question number 2. Where did she find her interest in the sciences? Was it A, at grade school, B, at New York's Free Museums, or C, at college? Yes, the correct answer is B, at New York's Free Museum. After Madrid attended Hunter College in New York, she was addressed by one of her professors, who would later become a Nobel Prize winner, Rosalind Yalow. Rosalind saw the potential in Madrid and pushed her to apply for a graduate fellowship in the field of physics. Madrid finished her postgraduate study at University of Cambridge, received her MA from Radcliffe College, and received her PhD from University of Chicago.
Dresselhaus's main area of research was nanotechnology, and she focused a lot on carbon and graphite. Her extensive research on carbon even earned her the title of the Queen of Carbon Science. She is known for unraveling the electronic structure of carbon, as well as making major contributions to the discovery of carbon nanotubes and graphene, which would eventually help to develop technology that is based on thin graphite. Some of the nanomaterials that she made even served as the foundation for lithium-ion batteries. The photo to the left shows Dresselhaus holding a carbon nanotube model. Other than nanotechnology and carbon, Dresselhaus studied the magnetic, optical, and electrical properties of semimetals. From this, she learned more about energy and electric charges, which would help her later in her career. She also pioneered techniques to study the electronic and thermal properties of thin materials. Finally, her research on all of these different materials over the years contributed to her being able to use quantum structures to improve thermoelectric energy conversion and update theoretical equations. Question 3. Her extensive research on carbon and carbon nanotubes earned her which title? A, Queen of Nanotubes, B, Queen of Carbon Science, or C, the Carbon Queen? If you said B, you are correct. She was known as the Queen of Carbon Science.
As far as achievements go, Mildred figured out the electronic structure of carbon from her studies of the electronic band structure of graphite and other carbon structures. This paved the way for the discovery of fluorines, carbon nanotubes, and graphene. She also served as the president of both the American Physical Society and the American Association for the Advancement of Science. Mildred was the first woman to be appointed Institute Professor at the Massachusetts Institute of Technology in 1985. Other achievements of Mildred include her being the first individual winner of the Kavli Prize in Nanoscience in 2012, along with the Presidential Medal of Freedom in 2014. She also wrote a book about fullerenes, also known as buckyballs, called Science of Fullerenes and Carbon Nanotubes. Last but not least, she pioneered experimental techniques to study the electronic and thermal properties of thin materials, which are high-purity materials and chemicals that are used to form substrates. Question 4. What are fullerenes known as? A, bouncy balls, B, sticky balls, or C, buckyballs? If you chose C, buckyballs, you are correct.
Some of Madrid's most memorable awards are in 1990, where she was the first woman to ever win the National Medal of Science, followed by in 1997, where she received the SGL Carbon Award from the American Carbon Society. Later, in 2009, Madrid was the second ever female to receive the Vandiver Bush Award. followed by in 2012, where she received the Enrico Fermi Award, where again she was the second ever female to receive that award. Finally, in 2015, she was the first female to receive the IEEE Medal of Honor. Madrid won other awards throughout her career, but these were the ones that made her stand out from the rest. She encouraged more females to pursue a career in physics by creating scholarship opportunities for young women. Madrid impacted the science world through her achievements, but also through her love for physics to help more women join the field until she died in 2017 at age 86. For our last quiz question, what was her first award that she was the first ever woman to receive? Was it A, National Medal of Science, B, IEE Medal of Honor, or C, Vandiver Bush Award? Yes, it was A, National Medal of Science.